Hi Algebra 1. Today's lesson is going to continue through factoring, and we are going to be talking about some of the special patterns that we learned last week when it came to multiplying special binomial cases. Well, today we're going to use those same patterns to work backwards and to factor based on a pattern. We will be in 8-7, which is on page 511 in your books. And you'll notice as I go through, if you are following along with your book, that I have been pretty selective on the example problems that we're going to do today. So the first thing that we're going to be starting with, you can see on the board here, and it is the same perfect square trinomial pattern that we talked about last week. However, when we were dealing with this, we were going from this direction to getting our answer. Today, we are going to be looking and recognizing a pattern here so that we can get our factored form. And so the purpose of using patterns, just like I said last week, is to maybe make your life a little easier. But if you didn't remember the patterns when you were multiplying, you knew that you could always just FOIL and still get the right answer. Same thing is going to apply here. If you don't remember the pattern to make your factoring easier, you can still use your X forms and get the right answer. So I'm going to demonstrate both ways for you today and just see how, or help you see how everything kind of works together and uses the same type of thinking. Okay, so last week we talked about perfect square trinomials and when we are squaring a binomial. So if we had two terms being added and the quantity being squared, we knew that really meant we're taking a plus b, multiplying by a plus b, and then we had to FOIL. Same thing here, just a subtraction sign. A minus b squared, quantity squared, is the same as a minus b times the quantity a minus b. Okay, so our example that we're going to start with is x squared minus 12x plus 36. That's problem 1 in this section, by the way. The first thing that I want you to get used to seeing is that we can recognize this as a pattern if we think in terms of perfect squares. So I'm going to write this again as x parentheses squared minus 12x. And what's 36? It's a perfect square. It's 6 squared. Well, if I look at these numbers and see I have a perfect square here, I have a perfect square here, and this middle term happens to be double this times this. That matches this pattern perfectly. So I can say, oh, that's my A, that's my B. I know this is x minus 6 quantity squared. Okay. Now, you might be thinking, well, Mrs. Agate, you're an algebra teacher. Of course, that was easy for you to see. That's how I'm trying to get you to see that recognizing a pattern is helpful and it makes factoring very quick. However, I would never require you to solve it this way. First of all, I can't even know if that's what your brain's thinking. But let's say you forgot this special pattern and you were like, I don't know. I'm just going to use my X form. Well, great. Let me show you how that works. Let's draw our X form right here. I don't have a lead coefficient other than 1. That's okay. Remember we just learned that it's really A times C in the ceiling anyways? 1 times 36 is 36. My B still goes in my basement. And using our shortcuts, we know that if this one's plus, it means both signs are the same. This tells me what they both are. So I have two negative numbers here. I'd also figure that out working through the pattern that I know to be true about my X form. What multiplies together to get me 36, but adds together to get me negative 12? Well, that's negative 6 and negative 6. So if I were to write that, x minus 6 times x minus 6. These are the identical same number, so I have two of the identical same binomial. Well, hopefully now you're seeing That is x minus 6 quantity squared. Whether or not I recognize the pattern or use my x form, I'm still going to get the right answer. Okay, let's take a minute here. I'm going to erase this and write down 2 practice problems that I want you to try. I want you to try to see it for the pattern that it is. However, just like in real life, if you don't see the pattern or you aren't feeling comfortable with that, use your x form. I've got 1 practice problem and 2 practice problems. The second practice problem, you'll notice, is a little bit more tricky. So we'll take time to discuss both of these. Here you go, 2 practice problems. X squared plus 6x plus 9. Try to find it in the pattern and factor it that way. If in doubt, use your x form. 4x squared plus 20x plus 25. Again, try it with your pattern, and if not, use your x form. Okay, pause the video, try these 2, and then we'll go over them together, and I'm going to go over them using the pattern. Okay, so go ahead and pause the video and come back when you're ready. Okay, the first thing that I want to do is recognize that I have my first term is a perfect square. My last term is a perfect square. And what is in the middle is this times this doubled, which is the pattern we learned last week. So I know that's my A plus my B. Oops, I'm writing it literally instead of thinking about my problem. X plus 3 quantities squared. Now again, if you weren't feeling comfortable with the pattern and you solved this using your x form, you would have gotten the same exact answer. Okay, let's look at this next one. Because while the pattern is still there, it might be a little bit harder to see. So if I look at this, I know 4 is a perfect square, and I know x squared is a perfect square. So I would write that like this. 4x squared is 2x quantity squared. Because if I squared this, I would get 2 squared x squared, which is 4x squared. So if I think backwards through my power rules, 2x is what's being squared there. This last number, 25, is a perfect square as well. And I see that as 5 squared. Noticing in the middle that this 20x is my A times my B doubled. So that means it follows this pattern perfectly. So my answer is my A, or my first term that's being squared, plus my second quantity squared. Now, if you had done your x form, you would have had to use divide and slide or your table method because I have a lead coefficient other than 1. Is that possible? Absolutely. Are you feeling really comfortable with it? Maybe you are. So everybody's brain works differently through this. And some of you might say, actually, I see this pattern so much better. That saves me so much time. Wonderful. Somebody else might be saying, I'm not really seeing the pattern, but I feel really comfortable with divide and slide. Great. Or maybe you're feeling really comfortable with the table method we did yesterday. Great. If you are somebody and you're saying, I don't see the pattern, I don't feel good about divide and slide, and I don't feel good about this table method, what that means you need to do is to get in the book and practice one of them and get feeling very good about one of them. That might mean you spend a little bit more time on Khan Academy, looking around at all the helps that they offer connected with your assignments. That might mean you have to email me and request a Zoom one-on-one. Great. Either way, you need to be feeling comfortable with one of the methods so that we know that you're ready to be moving on. Okay, that's it for this pattern that we talked about. We're going to spend a few minutes talking about the other pattern that we learned last week, and that was difference of squares. Now, when it comes to this one, if you remember, we learned a new math vocabulary word called conjugates, and that is when I have two quantities that have the same terms, same position or same order, but one is adding and one is subtracting. And we spent a lot of time going over this in the video last week, that a special thing happens with conjugates. When you FOIL them, the outside and the insides are opposites of each other and they cancel each other out. So our results when we multiply conjugates gives me something we've been calling difference of squares. Both terms are perfect squares and they're being subtracted. But notice there's only two terms in these. So that should be one of your first signs of recognizing this pattern. I've got only two terms. The next thing I need to see is, oh wait, they're not actually both perfect squares. Because remember, z squared is z being squared. And then 9 is 3 being squared. So in this formula, this is my first, or my A, and this is my B. So how I factor them, I'm going to make up two conjugates. One is going to be addition, and one is going to be subtraction. And there's my final factored answer for this difference of squares. However, remember I told you, maybe you're not feeling great with these patterns. Maybe it's not something that is easily recognizable for you. I want to show you how you can still use the X form on this certain pattern. You might be saying, wait a minute, how can we use an X form when there's only two terms? Well, I'll show you. I'm going to rewrite it in standard form. Remember, standard form is ax squared plus bx plus c. Well, in this problem, I've got my a, z squared in this case, and I have my number. But I don't have anything else in the middle. I don't have that b term. Or do I? It's there. It's just this. How many z's are in this quadratic? Oh, 0. So let's write it as 0z. So this difference of squares is the same exact thing as this. Now I have all of the necessary parts to use my X form. Here I go. AC goes in the top or the ceiling. My B goes in my basement. So now you can see how we think through this actually. What two numbers multiply together to get me -9, but add together to get me 0? Well, if two numbers are adding together to get me 0, I know they are opposites of each other. One's a positive and one's a negative version. So in this case, a -3 and a +3 would work there. Well, let's translate that into my binomials. Oh, wait. I have it already. My conjugates. The fact that this is negative and this is positive already tells me it's going to be a conjugate. Okay. I have one more example that I want to do with you in this method, and then I have two practice ones. But the next example that I want to do together here is going to show you, excuse me while I get organized here, is going to show you that there's actually a lot of benefit to memorizing this particular pattern. Okay, so the second one that we're going to do together, let's see what's going on here with my homemade system, is 16x squared minus 81. Okay, so let's make these difference of squares a little bit harder to recognize. The first way I'm going to go through this is by showing the pattern, making the pattern obvious. I've got 16x squared minus 81. Well, I need to recognize that first of all I have two terms. They're being subtracted. Could it be difference of squares? Well, yes. I'm going to look and notice that each component is a perfect square. This one I could write as 4x squared. Notice I'm using the parentheses. And then I know 81 is also a perfect square. Well, if I just use my pattern, I know this is my A and this is my B, so I just need to make two conjugates. One with adding the two parts, one subtracting the two parts. And there I go. There's my factored form there. But remember in the last example, I said that if you don't recognize the pattern, you can still use your X form. Well, let's look at this one. 2 terms. How do I write it with 3? Well, that's where I say, well, I'm going to write it as 16x squared plus, well, there are 0 x's there. This is not a lie. But notice what happens here when I use an X form. I've got some really big numbers. A times C goes in my ceiling. Well, I already did the math here. That's negative 1296. My B goes in my basement. Now remember I said in the last problem, if I'm getting 0 as my sum of 2 numbers, I know they have to be equal and opposites of each other. One's going to be positive, one's going to be negative, but they're going to be the same number. Well, what am I really finding then? How would I find what 2 numbers are the same that multiply to get me 1296? I'm actually just finding a square root. So while this looks complicated, in this particular pattern, it's not so bad. So what's the square root of 1296? 36. Wow, we've done a lot of work already and we haven't even finished. Because I have a lead term of 16, that means I have to use divide and slide or my greatest common factor table. So I'm not even done yet. So you can see why using a pattern is really helpful in this case. Can I keep going? Sure. I have x, one that has to be negative, sorry. X minus 36 times x plus 36, divide by 16, reduce, simplify, slide, and I would still end up here. But notice by recognizing my pattern and making my conjugates, I was done. So if the numbers are a little bit higher, the pattern is so helpful. So I would encourage you to use an X form as a last resort, for sure. Use it though, but look for the pattern to make your life easier. Okay, I'm going to erase this quickly and give you 2 practice problems. Again, I encourage you to try to find the pattern in order to factor these difference of squares and to use X forms if necessary. The second one particularly would make an X form tricky, just like that one we just did together. Okay, here's your 2 practice problems. S squared minus 16, 2 terms, subtraction, perfect squares, boom. Or 25d squared minus 64. That one might be a little bit harder to see the pattern. But go ahead and pause the video, try these 2, and restart it when you're ready to go over it. Okay, here we are. I need to recognize my pattern, s squared minus 4 squared. Great, that's my A, that's my B. I make my conjugates. S plus 4, S minus 4. Done. Patterns are really helpful. Look at this next one. I don't want to do all that work with that X form. Really big numbers, a lot of divide and slide, or my greatest common factor table. Whew. Let's just recognize our perfect squares in here. 5d squared is 25d squared. Minus, well, we know that's a perfect square. 8 squared. That's my A. That's my B. Let's come up with my conjugates. 5d plus 8, 5d minus 8. And there we go. There's my final answer for the factored form there. Okay, that ends this lesson using our special patterns. But remember, the special patterns are supposed to make your job easier. If they're not, use your X form in your divide and slide or greatest common factor table. There's suggested book problems listed on RunWeb and your note handout, and there is no Khan Academy assignment for today. Don't worry, there's 2 tomorrow. So practice these problems, get comfortable with more factoring, and enjoy the rest of your day, and I'll see you tomorrow.